Today I'll be discussing Lab 1, which is on charge tapes. So for the purpose and introduction, for this lab we had to collect data to understand the transfer of electrons between a charged item, which we chose a pen, and a neutral object, which is a tape, and inspect the charged tape's interactions with other items. But more specifically, we'll try to make one charged piece of tape, which we call the U-tape, change position based on the electric field of another U-tape we create. And then using the distance between the two tapes and some fundamental physics concepts we'll discuss, we can actually calculate the charge of tape in question. And so the result I got from this was a charge of 7.19 times 10 to the negative 9th coulombs. And some fundamental ideas to discuss before we go into calculations in the glow script are some formulas. And so to find the electric force exerted on a charged object, we'll actually use Coulomb's law, which explains why opposite charges attract and like repel. And that's at the top right here with a constant k of 9 times 10 to the 9th. And so the second one is a formula for calculating electric field, and this is what is causing the second U-tape to appear to be floating, which we'll see in a little bit. And then the relationship between force and electric field can actually be found with this third formula right here, which shows the force of a second tape is equal to the charge of the second tape times the electric field of the first tape. And then lastly, when the U-tape is quote-unquote floating, the electric force is equal to the gravitational force. And so for this lab experiment, we have some assumptions to do before we get into it. So the first one is the center of the charged piece of tape will act as the point charge, which is a halfway point. The second one is that each U-tape is created has the same charge. Third is that air resistance is negligible. And then fourth is a clear tape is around 1 gram per meter. And so on the left, you can see how we create the U-tape, which is having a base tape and then ripping off the U-tape after sticking it, and then that'll create the condition we want for it. And then you can see on the second photos how we create this experiment with having that 2 U-tapes and then one close to the second one, which appears to be floating. And so the data I got from this lab was a measured distance of 0.015 meters and then a mass, length, and width discussed or shown right there. And so with all this and the formulas we discussed, we can do some calculations. And so the first is finding the number of atoms, which is just surface area, which is length times width, over angstrom. And so with that, we find the number of atoms. The second after that is the charge on tape. And then we can use the F grav is equal to F electric when it's floating formula, and then equal those to each other, and then solve for QB, which is a charge on the second tape, which is floating. And then after doing that, we find that. And the last one is the number of excess electrons. And so we can do that by finding the charge on tape we just found and the electron charge for any electron. And then after dividing that, we get the number of electrons. And so now we have the glow script code I used. And so first I had to input the constants of K, Q, the tape mass, and then the positions and the charges of each particle. And then to find the electric force with gravity, I've made a definition in Python. And it uses R mag and R hat. And then so does the electric force, the second one, but we don't incorporate gravity in this one. And then lastly, we have the definition for finding electric field, which is just using the formula we discussed earlier and manipulating it to solve for E. And so after that, we have the results, and we have the results for electric force on tape B and the gravitational force on tape B, which you can see is the same one, but in one is the gravitational is negative and electric is positive, and that makes sense as the picture on the right shows the tape B and then the forces, and then the green is the electric, orange is gravitational, so you can see positive pointing up, negative pointing down. And then we have the electric force on tape A, which is the only force, and it's also the negative, so it's pointing down. We also have the charge, which I found calculating, and then we have the electric field for both of them on each other, which are the same, but then one is negative. And so lastly, we had to answer some questions. So if the electrons had a positive charge and the protons had a negative charge, which is just swapping them, then there would not actually be a change in observation as it would cancel out. This means that the tapes would have the same charge and repel each other as well as repelling the oppositely charged pen. So honestly, there'd be no real measurable effect and have the same conclusion as we would if it was the same, which electrons being negative and protons being positive. And then comparing the values of the charges of the two models in the experiment, I can see that the line charge accurately depicts real life scenarios since there's many more protons in question, and then this is in contrast to just having a point charge with one charge. That's all, and thank you so much for listening.